AP Psychers. In today's video, we are going to be talking about the 2019 Research Method FRQ. This is one of the two FRQs that were offered on the 2019 AP exam. At this point, on March 23rd, I think it is especially valuable to go back and look at Research Method FRQs. Of what is publicly available today, and what the College Board has determined as of today, the AP exam is going to be a take-home, 45-minute exam, FRQ only, and there seems to be the intent that the questions they ask are not ones that you can easily Google. With that in mind, I think it's more probable than not that you see quite a few bullets asking you to apply research method concepts. So we're going to try over the course of the next couple weeks to go back and verify that we still in fact have the skills that we harnessed back in Unit 2. The FRQ that I provided basically described Halloween. It didn't outright say the word Halloween, but it described an annual holiday or an annual activity where children wear masks and go out from door to door receiving candy. In the scenario, some of those children arrive alone, others arrive in groups. Over the course of the night, the psychologist described in the scenario asked half of those children to remove their masks when they arrived at her door. The other half of the children left them on. The psychologist then told every child to take only one piece of candy. She then went inside her house, leaving the bowl of candy outside. This gave children the opportunity to take additional candy. The psychologist measured the percentage of children who took additional candy. The psychologist's hypothesis were that children would take more candy when they were alone, and that children would take more candy when they were masked. Below, they provided a bar graph, or at least a series of bar graphs, indicating the results of her study. The bullets asked then indicated several of the skills that we've been harnessing and working on all year. As a mnemonic back in Unit 2, whenever we see the word operational definition, we need to know that we're looking for the most precise definition possible. The mnemonic that we used is, to me, this looks like it is the word operation. I think about the game Operation. If you've ever played the board game Operation, you have to be very precise in order to actually win, in order to actually achieve any of those tasks. With operational definitions, we're looking for the most precise definition possible of the dependent variable. In this study, the hypothesis, or at least the series, let's work with just one hypothesis. If the children are masked, then they will take more candy. That's a very simple hypothesis. It's just a rewording of the hypothesis in the prompt. The reason I put this in the if-then format is over the course of the year, we've been working on the skill of putting a statement in an if-then hypothesis format, and then knowing that after the if is always the independent variable, and after the then is always the dependent variable. If you're able to put a hypothesis in this format, this will always work. And there's an easy mnemonic to know the difference here. The word if starts with I, independent variable also starts with I. So if you can put a statement in the if-then format, you'll always know which variable is the independent variable, and you will always know which variable is the dependent variable. The prompt asks you to operationally define the dependent variable. You would easily then take what the dependent variable is more candy, and in your statement write, the operational definition of the dependent variable is the percentage of kids or children who took additional candy. Just writing the word candy is not sufficient. The best way of doing operational definition bullets is to look right into the prompt. The prompt gives you the precise way. If you look at the prompt, it says, the psychologist measured the percentage of children who took additional candy. The word measured should jump off the page. Whenever you see the word operational definition as a bullet, once you find the word measured in the prompt, if you just copy the sentence, you basically always will score. It tells you the precise way that the candy element of the hypothesis was measured. So an appropriate answer would be something like what I have here at the bottom. The operational definition of the dependent variable is the percentage of children who took additional candy. Now that we have a recreation of the bar graph on the board, we can simply go right to the prompt and find what each of her hypotheses happen to be, and whether or not the data from the bar graph supports or refutes her hypothesis. Her first hypothesis was that children would take more candy when they were alone. Let's take a look. Solo is in blue, and we notice that in each condition, the blue bar is shorter than the green being in group. That would mean that her first hypothesis was incorrect. So her first hypothesis was not supported. Her second hypothesis, though, argues that children would take more candy when they were masked. We notice here how each bar in the kept the mask on condition is higher than the removed, indicating that her second hypothesis was supported. So in order to answer this bullet, you would need to make both of those points. You would say something along the lines of, the data does not support the first hypothesis, that children would take more candy alone. However, the data does support the second hypothesis, that children would take more candy when they were masked. The third bullet asks you whether or not her study can be generalized. Can the study described in the prompt be generalized? Generalization is a term that we saw back in Unit 2. When we first described the process of generalization, it was in the context of surveying, where it's essential that you use random selection, sometimes called random sampling, where you might have 1,000 members of your community, but you need to randomly pick, let's say, 40 of them, and only administer that survey to 40. If you think back to Unit 2, we actually did an activity where you shuffled a big deck of magic cards and you pulled out the top 5 or 6 to see whether or not that random collection of magic cards represented the entirety of the deck really well. That was the activity that we did with generalization. What does that mean in the context of this study here? Well, what it is asking is, could this psychologist take her study that she conducted on her front porch and use that to generalize the behavior of children all over the world? Are her conclusions generalized across everyone on Earth? There are a few different reasons why they cannot be generalized. The first is a term back from Unit 2 called sampling bias. She only used her community. As a result, you can't take the results of one community and apply that broadly across the entire world. That's simply not fair to the rest of the world. There's different cultures, there's different socioeconomic conditions. That's what we call sampling bias. The example that we used when we first described sampling bias would be if we conducted a survey, I gave it to each of my seniors taking AP Psychology, and asked them to freely administer it to whoever they wanted in the school. Chances are a bunch of 12th grade seniors are going to administer the survey to primarily 12th grade seniors, maybe a couple of juniors, and I'm not going to get much insight from underclassmen. And if I really want to get an overall understanding or an overall sense of opinions at the entire school, I need to ask freshmen and sophomores too. And if I were to conduct a survey in that manner, I would get primarily the opinions of upperclassmen. That is a case of what we call sampling bias, where she only used her community, she failed to randomly select. If you're conducting an experiment like this, or you're conducting a research method like this, what you really should do is randomly get a collection of children from the community. That way all children across the whole community have a possibility of being selected, and then use that for your participants. Just sitting there on your front porch and letting kids walk up and utilizing that as your means of data collection is not valid, not scientific, and would not be accepted by the greater scientific community. So the main reason why her research is not generalized is the lack of what we call sampling, or random selection. She did not randomly sample, she did not randomly select. She exhibited what we call sampling bias. The fourth bullet asked you to evaluate why the scenario described in the prompt is not a naturalistic observation. Let's first quickly define what a naturalistic observation is in the first place, and then use that to go back and answer the prompt. Naturalistic observation was a term from Essential Task 2.2 when we described the 3 forms of descriptive research: surveys, case studies, and naturalistic observations. A naturalistic observation is when you go into a natural setting. So I'm talking about you go into the cafeteria during lunch, you walk around the mall and observe shoppers, you go to the basketball games and observe the fans, some type of natural setting. So not a laboratory, absolutely positively not taking participants and bringing them into the lab. Assuming that you do this in a natural setting, the next bullet, and this is the one that she failed in her study, was not interacting with the participants, meaning you first simply cannot interact at all. And she did that. She spoke to the participants, she spoke to the children in the community. That is an issue. She spoke, She interacted. Not naturalistic if you are interacting with the researcher. In 2, she actually manipulated whether they wore a mask. If you tell them, take one piece of candy, if you tell them to take a mask off or not take a mask off, that is not a naturalistic observation. These children are not acting natural. They are changing their behavior as a result of the interaction that they are having with the psychologist. So as a result, there are at least 2 issues in this study as to why it is not a naturalistic observation. She interacted with the participants, cannot do that, and you cannot ask them to take a mask on or keep their mask on. That is a manipulation of a variable. We leave that for experiments. Naturalistic observations and experiments are not the same thing. The final 2 bullets are in the traditional format, so we'll just briefly talk about both of them. Again, the main focus of going back and doing this FRQ was to emphasize research methods. However, modeling is a term that we described back a few units ago in Unit 6, Behavioral Psychology. Modeling is the process of observing and then imitating. It is a synonym really for observational learning. So in this prompt, if you described the children observe, so they watch others take candy, and they themselves now copy that behavior, and perhaps, since this is a study on taking additional candy, maybe they are copying the behavior of taking additional candy. That would sufficiently score. De-individuation is the term that we used when we described the scenario at the basketball game almost 2 decades ago at this point, the Malice at the Palace, when people feel anonymous. And as a result of feeling anonymous, they lose self-restraint. They lose their self-awareness. And it kind of triggers that mob mentality concept that we described back a few units ago. So now children are willing to take more candy when masked. That's the key concept here. If you feel masked and you feel anonymous, you might feel like you're blending in with the big group that you're with, and now all of a sudden you might be taking more candy than you otherwise would. That would be how you score the de-individuation bullet.